Hello and welcome everyone to today's conference session, Digitalization of Machine Tools and Cutting Processes as a Measure to Improve Productivity. I'm Michelle Jacobson, the Assistant Editor of GIA Media Manufacturing Group of Publications. Today's medical developments, today's motor vehicles, today's e-mobility, and aerospace manufacturing design. I'm excited to introduce our speaker today, Frank Beeckman, Product Sales Specialist at Marposs. Beeckman has experience in capital equipment sales as well as machining background, providing him with excellent knowledge and understanding of manufacturing and its ideologies. He has spent many years as an application and sales engineer, selling advanced machine tools, as well as working for OEMs to tier ones on down to mom and pop shops, from aerospace to US Defense to the Federal Bureau to Apple. His machining experience includes aluminum and cast iron castings, as well as prototype stampings, building, and machining metal forming dies. Now, before we dive into his presentation, I want to remind everyone that there will be a Q&A session following, so you can submit any questions you have in the Q&A icon in the control panel. We'll get to as many questions as possible. With that, I'd like to go ahead and turn things over. Frank, the floor is all yours.
Thanks, Michelle. I'll begin by sharing my screen with everybody. Good afternoon. Welcome to my presentation of digitalization of machine tools and cutting processes. And again, my name is Frank Beeckman, Product Sales Specialist, Machine Tools for Marposs Corporation. Topics to be covered will be a brief company overview, MMS, which is Marposs Monitoring Solutions. You'll hear that throughout my presentation today. Process monitoring, 3 areas of expertise: before the cut, which includes tool probes, part probes; during the cut, which includes artist capabilities, artist product lineup, artist application interface; and after the cut, probe software, and the see-through 4.0. And I'll share a product portfolio at the end. Marposs has one partner and many solutions, worldwide presence in 34 countries with 80 offices worldwide and more than 3,500 employees. Marposs global market segments are machine tool manufacturers, gauge makers, automotive and their suppliers, bearing, gear, and injector manufacturers, food industries, aerospace, electronic and semiconductor, glass, gas and oil, medical, electric vehicle, alternative energy, and defense. Business scope of Marposs Monitoring Solutions has a large expertise in data monitoring and machine process, but also develops monitoring solutions for almost any machine and CNC control, allowing us to not only monitor processes and detect anomalies, but make real-time automatic corrective solutions without the need for human intervention. MMS products combine sensorless, wide range of sensor hardware, smart modules, high-speed data processing, and intuitive software systems to optimize any machine processes. Our systems acquire and collect real-time data, provide advanced analysis of both machine cuttings and machine condition, arming the end user with data to analyze and troubleshoot workflow efficiencies and uptime problems, making fast decisions with real-time information. All topics discussed today will relate to increased tool life, increased machine life, reduced scrap parts, protecting expensive work pieces, reducing cycle time, reducing downtime of machines, enabling planned tool changes, enabling lights out operation, enable employees to work remotely, allow for automation of systems, provide real-time data-driven analytics, improve machine connectivity. 3 areas of expertise are before the cut, which include error-free tool setting, work offset programming and part location within the machine tool, part verification. During the cut, we have tool monitoring, process monitoring, machine condition monitoring, adaptive control, machine protection. As you can see in the picture on the right, we have 6 different screens showing. Those are actually 6 different sensors that are being displayed on the interface. After the cut, on-machine probing for confirmation of the process and also part inspection. Tool integrity check, tool breakage. Part inspection or verification like a CMM, process documentation and statistic analysis, SPC. Before the cut, we set standards to begin part processing. Multiple tool lengths and diameters can be set and saved in one program. Work offset can be saved with minimal effort and greater accuracy, so no more dial indicators or edge finders, and also eliminate human errors. TBD, solid concentric tool breakage and fast tool breakage cycle. The ML75P laser tool setter, tool presetting and verification, tool measured at cutting speeds, cutter profile integrity, and runout check. And the CCD camera technology is the VTS, which is independent of tool shape and dimensions, tool surface inspection, multi-cutter tool measurements, and measures tools from 0.010 millimeters. So very small tooling is measured through the VTS. We have wired and wireless contact tool setting, on-machine tool presetting, verification, tool wear and breakage, length and diameter is measured, accurate, and economical. Wireless optical and radio part probes, automated workpiece setup, on-machine part inspection, high performances of transmission range, speed, repeatability, and battery life. Compatible with all MITA touch probes, the T25, TT25, TT30, and T25P are all compatible with the wireless optical and radio part probes. During the cut, MMS provides the following services: tool and process monitoring, machine health monitoring, machine protection, digitalization of machines, data management tools. Implementation of a monitoring system, there are many points to consider. 1 is the data to record. 2, monitoring solution for the specific process. Level of integration, data storage, introduce new technology, and cycle time for inspection. All these are very important when implementing a monitoring system. The advantages: machine and tool monitoring, using electronic signature analysis from the machine axis, spindle, and tool to maximize each tool for the conditions that exist in real time. Flexibility of solutions. Every part type and cutting path is taught its own signature curve. Saving these profiles allows for easy part-to-part changeover and is transparent with no impact to production. Line efficiency and productivity. Predictable tool life improves production efficiency. Other advantages: greatly reduced number of damaged tools, allowing for greater scrap reduction. Improved throughput by eliminating stoppages due to quality issues, sorting, and part scrap. Ability to run tools more aggressively to reduce cycle time. Save additional machine count, which is money, by reducing operating hours. The data processing module, the GEM CPU, and the application GEMV Visu is smart and autonomous processing unit, real data graphing, graphical process information for analysis, multi-channel and sensor capable, works parallel to the machining process, constant check of tool and machine condition, allows programming of individual process parameters. Standard PLC interfaces to many different CNC controls. Remote control via the network, as well as data management ready and ready for Industry 4.0. We have many standalone sensor solutions, a large portfolio of sensors, as well as GEM AMS dynamic collision, the CMS for dynamic and quasi-static collision detection, the GEM-DS system for spindle growth monitoring, GEM-GP for general purpose monitoring, GEM-RO for tool holder runout detection, GEM-TP tool and process true power monitoring, and GEM-VM monitoring and analysis of machine and components. Again, more sensors to discuss: power monitoring, torque and axial forces, spindle growth monitoring, tool holder runout, machine health, coolant flow, coolant pressure, speed in terms of RPM control, percentage-wise, which is also called adaptive control, temperature monitoring, acoustic emission, strain sensor, data-driven manufacturing through see-through 4.0. Here is a good graphic of the interface of the ARTIS system. Up top, starting at the top left, we have the program number, tool number, and any additional process number that may be involved. The signal selected, so if you have 6 different sensors running at the same time, you have to choose one of them to look at in an exploded view. And this is what it looks like, or would look like. Scaling, so you have a signature of a signal based over time. Wear limit, you can see the red line at the top indicating the limit for the tool wear. The bottom right is the missing limit. You can see the red line for a tool missing. Area values, the green bar shows the learn process. The gray bars are the 10 previous processes, and the blue bar is the current process. And number 7, the signal curves that you can see. The green again is the learned signal curve. The gray curves are the last 10 processes, and the blue curve is the current signal. As you can see in this example, they all pretty much match each other, so the process is running correctly. And number 8 is the system status. Error detected, teach mode active. It just lets you know what mode the system is in. Real-time graphical result samples. Tool breakage, you can see where the signal spikes and initially is shown as a broken tool. Tool wear, as you can see in the highlighted area in the red circle, the tool is starting to wear more and more. And in a graphical sense, it shows that. Adaptive control, as well as tool missing. Typical system structure is the application, which is the visualization on either the machine screen, control screen, or on a PC running next to the machine or in a network. The GEM CPU, the amplifier and box, sensor or sensorless. Sometimes we can read digital drive data depending on the control model. And then see-through 4.0. Strategies of process monitoring, easily programmed, 5 different programming methods, fixed or relative limits, depending on what your need may be, individual process limits, even for the same tool. So if you have one tool that's doing multiple features on a part, you can separate those features and monitor them independently. Window feature for detailed signature monitoring. So you can construct a small window and just monitor that signal source there. After the cut is part inspection. Marposs supplies a full range of spindle probes to fit all machine tool types and workpiece shapes. Wired and wireless transmission cover all machine sizes and configurations. In the graphic, you can see I have some examples of cycles that are standard within the part inspection process. We also have, after the cut is the scanning probe. The WRSP60 scanning probe does TIR, roundness, concentricity, 3-lobe or part symmetry, comparison with a master, planarity, Also after the cut bore gauges, we have WRG bore gauges, automatic bore control integrated into production process, achievement of high quality machining tolerance, feedback to machine CNC for tool wear compensation, and it also communicates wirelessly. Data management software highlights, documentation of cutting process, error diagnostic and trending analysis, offline process evaluation, tool suppliers and comparison. Customize your report to fit your needs. Profit loss type of analysis is available. Proof of quality for each part. Support for cost accounting. Comparison report of tool data life. Notification of a pending tool change. Alarms tracing, counts, and analysis. Current service life, last and next change. Compare similar processes across machines, maybe even in different locations. Optimize planning on forecast. Detailed history of your tool library. CNC probing recorder is a software utility that can automatically collect workpiece inspection data directly from the machine tool. Production statistics and measuring results can be reported in a printed format or shared electronically. The main features are guided measuring process, automatic generation of CNC macro programs for data collection, automatic reading of memory through the macro variables, data exchange from CNC to an external PC connected through customer network, real-time data transfer via Ethernet, report generation in either PDF, TXT, or CSV format, CNC probing recorder report, statistical process control, or CPK, out of tolerance, upper and lower limits, etc. Report can be saved as a PDF or printed for process, batch, or a specific part. Main features, data collection per date and time. Easy to filter for process ID, batch, and sample. Data-driven manufacturing. Our See-Through 4.0 software is a database-supported management software tool which can be used either in a decentralized manner or centrally, both on a server or a client computer. It is solely designed for collecting and processing data which have been recorded during metal cutting and a machine tool using an artist tool and process monitoring system. Machine digitalization levels include: one is the physical shop floor, which is locally monitored and enabled on a Marposs PC. You can also share with the network cloud, local network accessible, desktop and mobile access, and locally managed as well. Analytics, smart data access, production planning, management team, maintenance group, engineering team, production, tooling, etc. All groups would need and like to see this information. Data-driven capabilities. So you can see we have trend report, alarm report, CSV report, and customized reports to give you various data based on the process and tooling. Excuse me. See-Through 4.0, machine health diagnostic, fully customizable data set, access from anywhere. Software applications, CNC probing recorder. The recorder collects measurement data coming from part inspection cycles, ready to probe. This is for operators without any knowledge of CNC languages. Ready to probe creates machine commands for part inspection and tool check cycles. This app can be found in your Play Store or Apple Store. It's readily available in those. AxiCheck permits to verify machine axes conditions before running production. Measurement results collection and management, measuring cycles easily programmed, machine axes condition and preventative maintenance. Products and solutions. As you can see, the artist product portfolio is kind of large, consisting of data management, process monitoring, evaluation analysis, data storage, machine monitoring, machine protection. All of those modules are coupled with the sensors that are below them, as you can see. So pretty large array of products. And I'd like to thank you for your attention today. If you need any more information, you can contact Jorge Pena, who is the Artist Product Manager, and you see his contact information. If you have questions on the MITA product, you can contact Sherrod Mundra, and there is his contact information. Or of course, myself, I'm available to answer any questions as well. And thank you for your time.
All right, Frank, thank you for those insights and going through all of that with us. We will go ahead and open it up for questions and start a Q&A session. So if you have not done so already, you can still submit questions. There's a Q&A icon you'll see in your control panel, and you can type them directly in there. In the meantime, we'll go ahead and get started with some questions we've already received. Frank, an audience member wants to know, what types of machines can these products be installed on?
Essentially any CNC machine tool. Some products are specifically designed for a FANUC control or Siemens control, but ultimately it does not matter. We don't need that interface. We can run a PC next to the machine. So again, it really doesn't matter what type of CNC machine that you have. We have a solution for your needs.
Fantastic. And then another question we have, do these products require high machine operator skill?
No, they don't. Essentially, we're taking the operator out of the equation by making smart decisions based on the analysis of the data. So essentially, we are removing any, I guess you could say, deep type of editing on the operator part. I mean, essentially, they just need to make sure that the machine is running and making parts. Everything else, tool wear, tool changing, all that would be taken care of without the operator's interference.
Great. And then another question. What types of work pieces do these products benefit the most?
Good question. Good question. Essentially, every workpiece from production, 1 million, 2 million, 10 million parts a year to one piece type of machining applications like the aerospace industry. Typically, the one piece are very expensive parts, and we have sensors and data that we can use to protect that workpiece from being damaged when a mistake is made through a bad program or an operator error or things like this. And then from production standpoint, it's good to know when your tool is about to fail before it fails. You don't want to run a broken tool or a missing tool through 5, 10, 15, 100 parts. Down the line, you have to go and get those parts out of circulation, and you got to find them. So that all costs time and money. So there is no specific target for us when it comes to volume.
Thank you. And we have another question. What is the ROI that's expected?
That's another good question. Return on investment depends on the application. Obviously, with many work pieces, high production, finding out when the tool is going to break before it breaks is priceless and can provide a very quick return on investment. From the single piece, work piece type environments, we want to protect that work piece. So we're going to tell you when there's no tool. We're also going to activate maybe the emergency stop circuit when a mistake is made and the programmer made an error or the operator got distracted or maybe came back from lunch and maybe forgot where they were at. Essentially, we're protecting the machine and the work piece as well.
Great. And then we do have a couple minutes left here. So if anyone else had any other questions they wanted to send in before we close, you do have the opportunity to do so. All right, if there are not any other questions, Frank, I want to send a special thank you to you again for presenting these insights today.
Thank you.
And I also want to thank everyone in the audience for taking the time to join us. We were glad to have you, and we are excited to see you and in the rest of our upcoming IMTS conferences. Hope everyone enjoys the rest of their day.
Yes, thank you. Have a great day, Michelle. Bye.
You too.